Number 9, find the x-coordinates of any relative extrema of the function, and then also in B we'll be finding where the function is increasing and or decreasing. Well, I know anything to do with relative and increasing and decreasing has to do with an f prime chart, so we're first of all going to need to find f prime. So I do notice there are parentheses, so I'm going to do a u substitution. U will equal x squared minus 4, du would equal 2x. All right, so if we're taking the derivative here, the derivative of u squared will be 2u times du, which is 2x, and then plug the u back in, so x squared minus 4 times 2x. So I'm just going to clean that up a little bit more. I'm going to put the 2's together, so my f prime will equal 4x times the quantity x squared minus 4. Okay, what's nice, it's already factored for us, so when we set this equal to 0, we can go ahead and notice that it's going to be pretty easy to do. This will be 4x and actually x plus 2, x minus 2. So my critical numbers are going to be 0, negative 2, and 2. So I'm going to go ahead and do an f prime chart. So negative 2 goes on my chart, 0 goes on my chart, and 2 goes on my chart. And then remember, I'm plugging numbers into f prime. If I plug something less than negative 2 into f prime, I'm going to get a negative number. Then I'll get a positive number, negative number, positive number. So when it's said to find any relative extrema, those would be relative mins or maxes. So there's going to be a relative min at x equals negative 2 and 2, and that would be because f prime changes from negative to positive. And then if I looked for relative maxes, that's going to happen just at x equals 0. And that's going to be because f prime changes from positive to negative. So the function is going up and then going back down, which creates a maximum. And then for part B, where the function is increasing or decreasing, f will be increasing wherever the derivative is positive. So we already have our chart drawn for that. So that will be from negative 2 to 0 and then from 2 to infinity. And that will be because f prime is positive. And then we'll say f is decreasing wherever f prime is negative, which will be from negative infinity till we get to negative 2, and then from 0 to 2. And that will be because f prime is negative. And then we got it on that one. Okay, number 10, find the x-coordinates, if any, of all relative extrema, again, minimums and maximums, of the function y equals 4 cosine x minus 2x on the interval 0 to 2 pi. So first thing that we want to do is, again, take the derivative. So y prime will equal, the derivative of 4 cosine x will be negative 4 sine x minus the derivative of 2x will be 2. So once I found the derivative, we want to find the critical number by setting the derivative equal to 0. So negative 4 sine x minus 2 equals 0. I'm going to add 2 to both sides, so negative 4 sine x will equal 2. Dividing both sides by negative 4, we'll get sine x equals negative 1/2. Okay, so a couple things that I'm going to do here. I'm going to draw myself a unit circle because I need to know where the sign is a negative number. So sine is the y value, so somewhere over here and somewhere over here, we're going to get a negative value. And then I'm going to think on my hand, where does the sign equal 1/2? That would be my ring finger being held down, which is going to be at pi over 6. So it's going to be some value of pi over 6 that has to do with being in these quadrants. So if this is pi, which would be like 6 pi over 6, the next one down is going to be 7 pi over 6. And then the next one, if this 2 pi is all the way around, which would be like 12 pi over 6, one right before that would be 11 pi over 6. So those are my two critical values. The next thing I want to do is, this is y prime, so we're going to do a y prime chart, not an f prime chart. And 6 pi. Okay, so I need to pick something before 7, 6 pi. I'm just going to pick pi. So if I plug pi into my derivative, the sign of pi is 0. 0 times negative 4 is 0, minus 2 is a negative number. If I pick something between 7, 6 and 11, 6, I'm going to pick 3 halves pi. Sine of 3/2 pi is -1 times -4 is 4, minus 2 is a positive number, and then something bigger than 11/6 would be like 2 pi. The sine of 2 pi is once again 0, so I'm going to get another negative number. So when I ask for relative extrema and looking at that chart, there's a relative min at x equals 7/6 pi, and that would be because y prime, not f prime this time because there's no f in this problem, y prime changes from negative to positive, and then there will be a relative max at x equals 11/6 pi, and that will be because y prime changes from positive to negative. And once again, that means the function's going up then going down, which creates a maximum. Okay, and number 11, find all intervals on which the function is increasing and or decreasing. In order to do that, we again want to do an f prime chart. I do notice that this is a quotient, so I get to use the quotient rule. So this will be my f, this will be my g. F prime will equal -1. G prime will equal 2x plus 3. So I'm ready to use the quotient rule. So we'll have f prime times g. So f prime times g, or high d low, however you want to look at it, minus f times g prime all over g squared. Okay, so now when I do this, I'll get negative x squared minus 3x plus 10. This is going to turn into plus, so when I distribute that x, I'm going to get plus 2x squared plus 3x all over x squared plus 3x minus 10 squared. 3x's are going to cancel out. When I combine them, I'm going to get x squared plus 10 over x squared plus 3x minus 10 quantity squared. Okay, to get the critical numbers, we're going to set the numerator equal to 0 and the denominator equal to 0. Okay, the numerator will never equal 0 because if I subtract 10, I'll get -10 square root. I can't square root a negative number, so no critical number from that one. This one will factor as x plus 5 times x minus 2. So my critical numbers will be x equals -5 and x equals 2. So making my f prime chart, I'll put -5 and 2 on there. And then without even trying anything, I notice from this formula, in the numerator, no matter what I plug in, I'm going to get a positive number. And in the denominator, no matter what I plug in, since I'm going to square it, I'm also going to get a positive number. So without even testing everything, all those intervals are going to be positive. That doesn't mean that we're increasing everywhere, because we do need to stop our intervals at -5 and 2. So we're just going to say f is increasing on the intervals -infinity to -5, and then again from -5 to 2, and then again from 2 to infinity, and that will be because f prime is positive. And then we don't really need to say anything about decreasing because it's not ever decreasing.